optimization, essentially you want to find critical points, singular points, and endpoints of the interval. Once you have that, you're going to evaluate the function there, and then the absolute max and min will be like within that interval if it's closed. And yeah, so just a few key points about optimization. There's a difference between local minimum and global minimum max. So a function on a closed interval is guaranteed to have one of each for most normal functions of one global min and one global max. It cannot have more than one of those. That is the absolute minimum or absolute maximum or absolute minimum of a function. But a local minimum or a local maximum is basically has to be either at a critical point or a singular point, or the endpoints. And essentially, what you're looking for, again, is where the first derivative is 0 or it does not exist. Those are the potential points. And you can use a second derivative test. So if the second derivative is less than 0, that's going to be a maximum. If the second derivative is greater than 0, that is going to be a minimum. Or you can also just see when you have this number line, if the first derivative goes from a positive to a negative, right? It's been increasing and now it's decreasing, so that's going to be a max. Similar for minimum, it's decreasing and now it's increasing, that's going to be a minimum. And also just keep in mind, at a critical point or a single point, it does not have to be a local max or a local min. It is not guaranteed to have extrema. In order to find global min or max, you have to evaluate. So once you determine, let's say you have a critical point at 3, you have to plug in 3 to the actual function, and then you'll compare all of your values of potential extrema. Your highest is going to be your global max. Your lowest is going to be your global min over a certain range. So just about those ranges. So if it's closed, you test the endpoints. But if it's an open interval, so that's denoted by kind of, rather than the square brackets, the curly brackets, you don't include the endpoints. So then it's possible for there to be no global extrema. Are there any questions about that? Okay. So a few other things. If the function is not continuous, sometimes this can mess up. And also if the function is unbounded. So let's say x squared goes up to infinity on both sides. It does not have a global maximum, but it does have a global minimum. But if you restrict that to a closed interval, then it will have a global maximum and a global minimum. So on an open unbounded, it's possible to have one, or it's possible to have neither, or it's possible to have both. But on a closed one, you'll have to have one and the other.